is analysis of carrier rotation modulation techniques for multi-level inverter. I am Shawnee. My team members are Divya and Gayatri. We are guided by Dr. N. Manaja ma'am. Our objective is to balance the power in the system and reduction of switching losses in cascade H bridge, and to validate the carrier rotation modulation techniques for multi-level inverter using MATLAB and utilize PWM techniques to minimize harmonic distortion. This is our block diagram. Each H bridge requires different DC source, and then each switches requires different pulse, and then pulses are generated by STM32 microcontroller that is connected to the load, and then load produces the output voltage and current waveform and current values. Circuit diagram for 7-level inverter, and this is the PWM technique circuit diagram for carrier rotation, and this is our MATLAB simulation. This is CHP and then gate pulse production, and we rotate the carrier wave in a clockwise rotation, anti-clockwise rotation, and then within positive and negative group and separately positive and negative group. And first we shift it by rotation of each carrier wave, and then by that we compare the each carrier wave with the sine wave, and then produce a gate pulse, and then obtain the voltage THD is a 22.66% and voltage waveform, and then output current waveform with 1.83% of THD, and then power balance, and then half cycle carrier wave. Every half cycle the carrier wave is rotated and obtain the gate pulse and then voltage and current output, and the THD is same for all the 7-level inverter of every rotation. And then we obtain for every quarter cycle we rotate the carrier wave and then obtain voltage and current waveform. And full cycle, for every full cycle we rotate the carrier wave and obtain it. So by comparing these three sections, full cycle, half cycle and quarter cycle, obtain an average switching frequency same, and then 60 and 120 degree shift gives more switching frequency and the power is not balanced, so we neglect the 60 degree and 120 degree shift. And then we rotate within positive and negative group with the same phase shift each carrier wave, and then half cycle rotation, quarter cycle rotation and full cycle rotation, and obtain that full cycle is require less average switching frequency, that means minimizing the switching losses, and rotation of carrier wave in an anti-clockwise direction in a separate positive and negative group, and obtain gate pulse, current of half cycle and quarter cycle, and full cycle obtain current and voltage output waveform, and then finally we obtain that full cycle required less switching frequency, and then voltage THD is less for highest level, and then carrier rotation techniques compared to other, it has lower THD and then reduced switching losses, and then power is balanced for full, half and quarter cycle, and then full cycle rotation in counterclockwise direction, lowest switching frequency with uniform pulses in all switches obtained as a conclusion. At conclude, full cycle in a rotated in a counterclockwise direction is best and produces a good quality output voltage. Thank you.